All right, so today we're going to start with a quick overview of the 00 network architecture. So we're going to start with a pretty simple setup in the middle, which are 3 validators, in this case located within the same data center. So when it's this validator's turn to build a block, it's subject to the full force of the public internet. Hundreds of thousands of inbound transactions, sometimes exceeding 80 gigabits per second, are all trying to send data to this one specific validator in the hope that it will include them inside of a block. This is not a bug, this is how these systems are designed, but we can do better, especially on the 00 network. So everything located, in this case, this cluster of validators located inside of a data center, we can build a defense layer around them. And so how does this defense layer work? Well, if you think about this defense layer, there's all these inbound transactions coming into them. But these inbound transactions are actually all running over either the public internet or the 00 network. So all of this inbound data are running on network links that are connecting into this data center. And if at every point where we have data flowing through into the system, we have a 00 device. So these are network switches that are not custom hardware. These are actually like off-the-shelf commercial components that you can go out and procure. There's a number of different platforms for qualifying in to work with the system. But this is using basically the best of private networking technology to provide a filtration layer for inbound transactions into a specific data center. So inside of each of these is a FPGA, a field programmable gate array, and it's configured in such a way to do signature verification, transaction duplication, and even more into the future, all hardware accelerated using these FPGAs. And so one of these boxes can handle 100 gigabits of inbound signature verification and transaction deduplication at line rate and support a huge number of validators downstream within a data center from that one component. Now, when we look and we expand this out and we say, okay, well, this is great for one data center protection model, but Solana runs in hundreds of data centers around the world. Ethereum runs in hundreds of different locations all around the world. This is true for most high-performance blockchains nowadays. So if we look at another data center that, again, maybe only has 3 validators running in it, you may think, okay, well, then we need to do the same thing. We need to create a filtration layer around it. We need to put these filtration boxes on the inbound and egress of these locations. And that is true. These data centers are also reachable by the public internet. And so if there's data coming into them, that also needs to go through the same type of system. But remember, 00 is more than just a filtration layer and a protection layer. It is also backhaul multi-hundred gigabit network connectivity linking all of these validator systems together. And so these 00 devices are connected by high-capacity dedicated fiber links. Maybe it's a single one, maybe it's 5 connecting a specific data center. And so data can move from inside of this protected ring to inside of this protected ring by transiting over the dedicated fiber and availability that 00 provides. At the same time, external inbound traffic can still come in, be filtered by 00 devices, and so each validator remains just as reachable to the public internet as it was before, no matter where that traffic is coming from in the world, but we've added this additional component to it apart from just the filtration layer. And this allows this validators in this data center and this data center to communicate much more quickly than they would be able to using the public internet. At the same time, there may be validators physically nearby. Let's just say for a minute that this is Singapore and this is Amsterdam. There may be a validator located in a nearby data center that's not within this network, or there may be a validator located in Frankfurt here. And these validators can still benefit from the double-zero network. They are able to still communicate with the validators inside by passing through these double-zero devices, which provide protection for the inside and still allow for transactions to come in from validators located outside of the network too. But if this validator is now suddenly trying to reach consensus with validators over on this part of the world, it can actually send data through the double-zero network by using a software tunnel to connect into this double-zero device, even if it's not located in the same physical data center. Now, there are limits, of course. If this is 500 miles away, it's not going to provide any benefit over the public internet, but maybe this validator is actually pretty nearby. Maybe it's running in a region just 50 miles away from where this data center is located, and so the metro connectivity is still pretty strong. And in this way, even validators that are not located on the double-zero network physically directly and are not operated in data centers where there's physical fiber backhaul connectivity can still benefit from using the double-zero network. Same in this example here when you're talking about something over in Frankfurt. And so this is kind of, you can think about this as a hybrid public-private network. There are components of this that are communicating over dedicated fiber contributed by double-zero network contributors, but at the same time, this is able to interoperate perfectly with public internet traffic and validators that are not located on the double-zero network and want no relationship with the double-zero network as well. This is a system that allows for both designs to coexist while also allowing us to accelerate the performance of high-performance blockchains.